In this lesson, we're going to look at derivatives using the product and quotient rules. First, we have the product rule. If you have a product of functions, in order to take their derivative, you do the first function times the derivative of the second, plus the second function times the derivative of the first. So again, you can totally use this formula. It works every time. But I also wanted to show you guys what we call the fish in F106, and it was inspired by our student Dustin Hadley, class of 2011. So it's still the product rule, it's just in a nice little concise graphic organizer. So to do the fish, you put the first function in the top left corner, then you put the second function in the top right corner. Next, you take their derivatives going down. So what you do is you start in the top left corner and you multiply these two functions together. Then you swing this around and you multiply those two functions together. But it's a fish, so we're going to put little fish lips right there, and that's to remind you that you add. And you can see you get the exact same formula as the product rule, but again, this just organizes your work. Next, we have the quotient rule. So when you have a quotient of functions and you need to take its derivative, you start with the lower function, then you times by the derivative of the top function, minus the top function times the derivative of the lower function, and it's all divided by the low function squared. To help us remember this, we refer to this as high and this is low, as in higher function, lower function. And we go low d high minus high d low all over low squared. The key is to remember that it starts low d high minus high d low all over low squared. So there's also a song. I kind of modified what I remembered from high school, which was so long ago. And I'll sing the first part of it to you guys. You're welcome. No, just kidding. I'll apologize ahead of time. Oh, I also have a YouTube video, so you know, casually, you can go watch that. All right, so anyway, it goes low d high minus high d low all over low squared. Use with f of x over g of x. It's the quotient rule. It keeps going. Watch the YouTube video. Good times. All right, so we're going to keep going. This example says differentiate using the product rule. Before we actually apply the product rule, I want to point out that you have two functions here. You have x, you have e to the x. Because you have a product of functions, in order to differentiate, you must use the product rule. So remember, to set up using the fish, you take the first function, put it on the left, take the second function, put it on the right. Then we take their derivatives going down. So the derivative of x is 1. The derivative of e to the x is itself e to the x. Next, you start in the upper left corner, you multiply these together, then you swing this around and multiply those together and put a little plus for the fish lips. So we go plus, and then the product of these. So our product rule is written out, and then we need to write our final answer, and we get x e to the x plus e to the x. This example says let f of x equal the square root of x times the quantity a plus bx, where a and b are constants. Part A, find f prime of x by first distributing and then using the power rule. So in order to do that, I'm going to rewrite x as x to the 1/2. And now we can distribute. First we multiply x to the 1/2 times a, so you get a x to the 1/2. Then we multiply x to the 1/2 times bx, so you get b and then x to the 3/2. Just a reminder, this is x to the 1/2 times x to the 1. So you add their exponents, so 1 plus 1/2 would be 1.5 or 3/2. Now we're ready to take the derivative. Remember, a and b are constants, so when you take a derivative, you can just drop the constant down. So I brought the a and the b down and then took the derivative of x to the 1/2 and I took the derivative of x to the 3/2. So I rewrote this as a over 2 square root of x by moving this x to the negative 1/2 to the denominator and then rewriting it with a square root. And I rewrote this as 3b root x all over 2. And last step, I want to combine these fractions, so I need a common denominator. So right here, I multiplied the top and bottom by root x, and then right here, square root of x times square root of x just makes x. So you have a plus 3bx all over 2 root x. Part B says find f prime of x by using the product rule. So we have root x as one function, and our other function is a plus bx. So I put this function on the left as x to the 1/2, and then I put the other function on the right. And now we're going to take the derivative going down. So here you get 1/2 x to the negative 1/2. A is a constant, so the derivative of a constant is 0. And the derivative of bx is going to be just b. Okay, to use the product rule or the fish, you start in the upper left corner, you multiply these together, then you add the product of these. So you get x to the 1/2 times b plus a plus bx times 1/2 x to the negative 1/2. and I rewrote this as b root x, and I rewrote this as a plus bx over 2 root x. Now we want to make common denominators, so we're multiplying this on top and bottom by 2 root x. This root x times this root x makes just x, so you get 2bx in this numerator. Over here I just dropped that numerator down, and now we can add the two fractions. And remember, when you add across the top, 2bx plus 1bx makes 3bx, and then I drop the a down. So either way, by distributing first or using the product rule, you're getting the same answer. This example says let f equal the square root of x times g of x, where g of 4 is 2, g prime of 4 is 3, find f prime of 4. So we want to take the derivative of f, and if you look at f, it equals a product of functions. Your first function is root x, your second function is g of x. So let's get it set up in the fish. So again, I wrote root x as x to the 1/2, and then I just put g of x right here, and now we're going to take their derivatives going down. So you get 1/2 x to the negative 1/2, and then right here you just get g prime of x. Remember, when you do the fish, you start in the upper left corner, you multiply these, swing it around and multiply those, and give your fish a mouth so you don't forget to add them. So I multiplied these together and got g prime of x times root x plus, and then I multiply these together to get g times 1 over 2 root x. The problem wants us to find f prime of 4, so next we're going to plug in 4 for x. We're getting close. G prime of 4 right here says it's equal to 3. We know the square root of 4 is 2. We know g of 4 right here tells us it's 2. And then we can simplify this down here as well. So you end up getting 6.5. This example says f of x equals, and you have this rational function, find f prime of x. You have a rational function, or we would say a quotient of functions, so we're going to use the quotient rule. Remember, to use the quotient rule, you start low and then d high. And then d high is the derivative of the top function. Then we go minus high, and then d low, and it's all over the low squared. Okay, so let's recap. It's low, and then d high, minus high, and then d low, all over the low squared. And now we simplify it up. So we're going to FOIL here, and then we're going to distribute here, and combine like terms. All right, I FOILed this out. I distributed the 3x squared to these terms and distributed the negative to all three terms. We got this, and it's still all over the low squared. And here's our final answer. This example says find an equation of the tangent line to the curve at the point 1, 1/2. Here's our function. In order to find the equation of the tangent line, we already have a point, we just need slope. To find the slope, we're going to take the derivative, and to take the derivative of y, we're going to use the quotient rule because we have a function on top and a function on the bottom. So for the quotient rule, we start low, then we do d high. Then it's minus high and d low, all over the low squared. So I rewrote this part of the problem as 1 plus x squared over 2 root x, and then right here I just rewrote this as 2x root x. So at this point, we could just take our x value, plug it right in, and we can get our slope. So I plugged 1 in for all the x's, and now we'll simplify. And you end up getting negative 1/4 for the slope. So taking our slope and our point, plugging it into the point slope formula, you get y minus 1/2 equals negative 1/4 times the quantity x minus 1 for the equation of our tangent line. This example says find an equation of the tangent line to the graph of f at the point 1, e over 2. So again, to find the equation of the tangent line, we need point and slope. We have the point, we just need slope. To find the slope, we're going to use the derivative. And last, to find the derivative of this function, because we have a function divided by a function, we'll use the quotient rule again. Again, we start low, d high, minus high, d low, all over the low squared. Now we're going to take 1 and plug it in for x to find our slope. Okay, and next I'm just going to simplify. So we end up getting that slope equals 0. And I made a little note, when slope equals 0, that means the tangent line is horizontal. And so we're going to go back to this point. If your tangent line is horizontal at this point, that means the equation of the line is just going to be a y equals, and then we use the y coordinate. So the equation of the tangent line to the graph of f at this point is going to be the horizontal line y equals e over 2. Okay, I have this note just to remind us, not every quotient requires the quotient rule when differentiating. So here's an example that shows that. It says let f equal, we have 3x squared plus 2 root x all over x. It says find f prime by first manipulating this function and then using the power rule. So again, we don't have to use the quotient rule. We could do low d high minus high d low all over low squared, but we don't have to. We can instead simplify this first and then take the derivative using the power rule. So first I rewrote it as 3x squared plus 2x to the 1/2 all over x. And so next what we're going to do is we're going to split this to two fractions. So we're going to go 3x squared over x plus 2x to the 1/2 over x. Notice I'm still writing f out here because I want to make sure that we're all aware that we haven't actually taken a derivative yet. So we still have the function, we're just manipulating it. And now we're ready to take the derivative. So the derivative of 3x is just 3. To take the derivative of this term, I'm dropping the 2 down. Then you take this exponent, you multiply it to the front, and then we're going to take this exponent and subtract 1. Remember, to subtract 1, that's the same as 2 over 2. So really, this is negative 1/2 minus 2/2 would be negative 3/2. The 2's cancel, and we end up getting 3 minus 1 over x to the 3/2.